Welcome back, children. In the previous video we learned about the meaning of correlation. Then we learned about the types of correlation, that is linear, non-linear, then positive, negative, then simple and multiple correlation. Then we learned how to assess the degree of correlation, which is divided into perfect, where positive and negative correlation is learned, then absence of correlation and limited degree of correlation. Now today we are going to learn, in this video we are going to learn how do we estimate the correlation, different methods of estimating the correlation, different methods to find out correlation. So the different statisticians have given different methods to find out correlation. One such method is scatter diagram, where we find out the relationship between the variables by using the graph, by using the diagram. It is a graphical representation. Scatter diagram is a graphical representation of the correlation. Then we have the method of estimating the correlation given by Spearman. He is a statistician and therefore his method is known as Spearman's rank correlation coefficient or rank correlation method. His method is known as rank correlation, ranking the relationship between the variables. Now if it is ranking the relationship between the variables, we can say that his study is based on qualitative variables. What are qualitative variables? They are attributes such as talent, skill, etc. Now in a particular competition where for example the recitation competition, different participants will be joining that particular competition and there will be judges giving marks for these students or the participants who are attending that particular competition, and they will be ranked according to their talent. Okay, so how much the judgment between the variables, how much the relationship between the different judges are related to each other. To know that, we use the Spearman's rank correlation coefficient. So the judgment will be made by 2-3 judges. So how their judgment is related, so that is found with the help of Spearman's rank correlation coefficient. That is why it is named as rank correlation coefficient or rank correlation method. So here he has given importance to learn the relationship between the qualitative variables, because in the second chapter you learned about the different types of variables, quantitative and qualitative. Qualitative variables are those variables which gives importance to attributes such as skills, isn't it, then talents, etc. But whereas quantitative variables are those variables which are expressed in numbers. So Spearman's rank correlation method learns about the relationship between the variables. Which kind of variables? Qualitative variables. The next method of estimating the correlation was found by Carl Pearson. Now Carl Pearson is another famous statistician. He has developed the method of estimating the relationship between the variables based on quantitative variables. He has given the importance to his study by learning the relationship between quantitative variables. So Spearman has studied about the relation between qualitative variables. Carl Pearson has studied about the relationship between quantitative variables. Now for class 11 this year, Spearman's rank correlation method is not there for you to learn. It is deleted from syllabus. You have to concentrate on the other two, scatter diagram and Carl Pearson's correlation coefficient or correlation method. Now first we will move on to scatter diagram. Now just as I told you now, scatter diagram is the graphical representation of the degree of correlation. Now we are representing the degree of correlation. We have learned about the degree of correlation, isn't it? Positive one, then negative one, 0, and limited degrees of correlation, high, low and medium, isn't it? So we are representing the different degrees of correlation based on a figure, that is known as scatter diagram. Now let us see what is scatter diagram. Scatter diagram. Now scatter diagram is the diagrammatic presentation of the degree of correlation. Now here mainly 5 degrees will be concentrated. The first one is perfect positive. Perfect positive is +1. I hope you all remember what is the definition for +1 degree of correlation. What is the definition? When two variables move in the same direction, supply and price, and that too the change is proportionate, we call it as perfect positive. Now how can we represent that in a diagram? This is a diagram where we represent x on the x axis and this is the y axis. Now what has to come to your mind is, if two variables are moving in the same direction, here we are going to represent perfect positive correlation. So positive correlation means what? When two variables are moving in the same direction, it is known as positive, and when it becomes perfect, when the change is proportionate, it becomes perfect positive correlation. So remember one thing in mind, when two variables are moving in the same direction, your curve will be an upward sloping curve. Just remember your supply curve, which you have learned in economics, your part B, microeconomics. What is the shape of the supply curve? Positively sloped curve. Why? Because the two variables are moving in the same direction. So the same supply curve I have drawn here, where it is upward sloping curve. Now you can see the dots given here, isn't it? What does the dots indicate? The dots indicate the degree of correlation. How can you learn about the degree of correlation here? See, one dot is in difference with the other dot, the same difference you can find, same distance you can find, isn't it? And they are moving in the same direction. One dot is just after the other, isn't it? So these dots are moving in the same direction, and that too in the same proportion, isn't it? That is why they are known as perfect positive. Okay, I hope it is clear to you. Now what will be perfect negative then? Negative correlation means what? When two variables are moving in an opposite direction, it is known as negative correlation. Demand and price both are moving in a negative opposite side, isn't it? So it will be a negatively sloped curve. Just think about the demand curve. That is what I have drawn here on the board. Now it is a negatively sloped curve, and you can see the dots here. Okay, these represents a degree of correlation. Here the dots are moving in the same direction, and that too in the same proportion, isn't it? That kind of a movement is known as perfect negative correlation, where it is -1. Okay, then comes no correlation, absence of correlation, next degree of correlation that you learn. No relationship between the variables. Okay, in that case it will be like this, no relation, it will be spread here and there. Okay, then comes the next one, positive and negative correlation, which will be represented as a limited degree of correlation. Positive and negative, it comes as positive but not perfect. What is positive correlation? Both are moving in the same direction, but it is not necessary that it should be proportionate. Both are moving in the same direction, but it will not be proportionate. Change in the price and change in supply, both are moving in the same direction, but their change will not be proportionate. If it is not proportionate, we can't call it as a perfect positive, we can call it only as positive correlation. So that is what is depicted here, positive correlation. It is an upward sloping curve. Here you can find both are moving in the same direction, but here you can find distance is less here, here distance is more, and some dots are spread here over there, isn't it? That means it is not perfect. That kind of a correlation is known as positive correlation. Next one is negative correlation. Negative correlation means both are moving in a opposite direction, so downward sloping curve, and here you can find both are moving in the same direction. See, here both are moving, but here you can find here the distance is more, here distance is less, again it is more, here it is less, again it is more, here it is less, like that. And you can see some dots spread here over and there, isn't it? As it is not perfect, we can't always say that it will stick on to the same line, but they are moving in the same direction. They will move in the same direction, but it is not perfect. If it has to be perfect, it should be proportionate. If it is not proportionate, it is not a perfect negative, but it is a negative correlation. So, these are the 5 degrees of correlation which we can represent with the help of a scatter diagram. So, with the scatter diagram, we can represent perfect positive, perfect negative, absence of correlation, positive and negative correlation. So, this is what the scatter diagram represents, diagrammatic representation of the relationship between the variables. So, first method is over. Next we are going on to Karl Pearson's correlation coefficient or degree of correlation. This degree of correlation is known as coefficient of correlation. Once again, degree of correlation, which are the degrees? Positive 1, minus 1, high, mid, low, then absence. All those degrees that you have learned in the form of a table in the last video, that is degree of correlation. The same degree of correlation, we name it as coefficient of correlation. Both are same. Okay. Now, I told you Karl Pearson has learned the quantitative relationship between the variables. He has given the quantitative method of calculating the correlation, and the correlation is represented by the symbol R. Okay. And Karl Pearson's correlation can be calculated by using direct method, shortcut method and step deviation method. As they are variables, there is no individual, discrete or continuous series, only variables. So, there is no, we won't be calculating, there is no individual or discrete or continuous series. There will be only one type of series or data, and we will be calculating those with the help of 3 methods: direct, shortcut and step deviation method, as we have learned for mean, calculating the arithmetic mean. So, in the next video, we will learn the calculation process of Karl Pearson's correlation method. Thank you.